What's up, guys? It's Mr. Brengle, and today we're going to be talking about the results from our Pendulum Lab. So you can see that I have the first tab open here, changing mass. If you remember, we took multiple masses. We had brass, aluminum, plastic, and wood, and we measured the period of each of those masses. And what you should see is that your average period up here, you can tell that these numbers are not really changing. And so when we graph the data, which I've highlighted what you're supposed to graph here, the mass and the average period, you can see that I've moved those over to the side, highlighted them together, and then made this graph here. If your graph does not look like this and it's super zoomed in, check your scaling over here on the left side, and make sure that it goes up to at least like 3 or 4 or 5 on the y-axis. To do that, you can simply double click on your graph, come over here to vertical axis, and change your maximum value to something other than what it's set at. When you zoom out, it should show it pretty flat. The only reason why it wouldn't be flat if you have data that looks like this is if it's super zoomed in and it's just showing these minor changes here. So looking at this graph, you can see that there is no relationship between mass and period. What that means is that as you increase the mass of the object, nothing happens to the period. Stays the same. So this flat line represents no relationship. And you can see that over here when we're answering these questions for changing mass. You're going to paste your graph in, and it says, is there any relationship between period and mass? The answer to that is no. So let's just go over here quickly to our virtual lab, and you can see I have the mass set at 100 grams. I'm going to go ahead and release it from 30 degrees, and we're going to time the period. It's going to go from right here over and back. When it comes back, I'm going to stop it, and we're going to check the period. Okay, so it's about 2.65 seconds. This is measured in milliseconds here. So that's with 100 grams. Let's reset it. Let's go to 200 grams. Okay, 2.7 seconds. Let's go to 500 grams. 2.7 seconds. It looks like I may have jumped the gun on that first one. So it's around 2.7 seconds. Now it's down to 10 grams. So we just went from 500 to 10, so that's a huge difference in mass. Still 2.7 seconds. Okay, so you can see that changing the mass here does not change the period. It's always going back to the same spot. Okay. All right, so we'll go ahead and move on to our changing amplitude. And you can see I kind of cheated here. I knew what was supposed to happen, so I've just got some mock data in here for you. And we are graphing amplitude and period. Period should be on your y-axis, amplitude on your x, and you're going to see similar results to what we just had on the first changing mass graph. You're going to see as we increase the amplitude here on the x-axis, nothing happens to the period. It does not change. So looking at these numbers, we can see that it's very consistent there at about 1.56. So you should see another flat line, which again, on your lab report, when we fill this out, you put your graph in. Is there any relationship between period and amplitude? The answer to that is no, because as the amplitude changes, the period does not. Again, if it looks like it's making, making peaks and valleys, then zoom out on your y-axis, and it will flatten out that line for you. Okay, and we'll go back to our virtual lab here. We'll go ahead and put our mass back at 100 grams. We'll leave the length at 4. Let's change the amplitude and let's see what the period is when we'll go from 50 down to like 30 here. Okay, so about 2.7 seconds. Now you'll notice that that's about the same as when we were changing the mass over here. So let's reset it. We'll go at 40 degrees this time. 2.7. 30 degrees. 2.7. 20 degrees. 2.7. Okay, so you can see that changing the angle or the amplitude also does not change the period here. Now moving on to the last one here, and just ignore the orange stuff over here for just a second. Let's just talk about the green. You were to change the length of your string, and I did a lot of lengths here. So I actually did more data points than what I had you guys do in class. And you can see that it's starting to look like a curve here. It should look like a Groot graph when you graph length of string and average period. Again, I have those things highlighted here. I've moved them off to the side and graphed them over here. You should have length of string on your x-axis, that's in the first column, and average period on the y-axis. So this is a period versus length graph. Now, again, you could interpret this as linear, and in fact, if you look at the r-squared value for a linear line, it is going to give you a very nice r-squared value close to 1 as well. But it's also, if I set it up for polynomial, then this is also a really nice r-squared value. It is supposed to be a Groot graph, which is the one that curves up like this and starts to flatten out at the top. So we're going to treat it as such. Even if yours has a better r-squared value for linear, make it polynomial, and we'll go ahead and treat it as a Groot. Now with a Groot graph, you do need to linearize that remember, Groot rhymes with square root. So it's y equals the square root of x. That's the equation for this graph. But instead of working with that square root to make things easier, if you just square both sides, it just becomes y squared is equal to x. So if we then graph y squared versus x, where you'll notice that I didn't change any of my x-axis values because that didn't change in the equation, but I have squared all of my periods here. So if I click on this, you'll notice up here where the equation is, it's h2 caret 2, which is this right here, h2, the first average period, squared. And then, so I entered that equation and I dragged it down. When you graph that, it comes out as a really nice line here, and I've got an equation right there for you. The r-squared value was 1.0. So, obviously there is a relationship here. And when you go to there's a little bit more to do on this part. You're going to paste your original graph in. Is there a relationship? Yes, the relationship is Groot. And then we linearize it on step 4. You'll paste your linearized graph, and then I want you to get the equation for a pendulum. And the reason for this is because the equation for the pendulum is going to explain all 3 of these tests. The only thing that you're going to find of these 3 things in the equation for the period of a pendulum is length. Length is part of that equation. So length does affect the period of a pendulum. And just for purposes of being consistent, let's go back here and we're going to start changing the length. I'm going to start at length of 1. We'll leave the mass at, we'll go to 200. And let's release from 30 degrees each time. Okay, so we'll start again here at length of 1. Okay, so we'll go from 30. Okay, about 1.8. Let's change the length to 2. Release from 30 degrees. 2.2. Change to 3. 2.4. Change the length to 4. 2.7, change it to 5. 3.0. So you can see that the period of the pendulum is increasing as I increase the length. And when we look at our data, as this length increases, you should see that that period is also increasing. Okay, so that will be about it for the Pendulum Lab. Make sure you take a look at the equation. I'm not going to ruin the surprise for you, but take a look at that equation. Make sure you understand that length, and then you'll also find that the acceleration due to gravity is the other thing that affects the period of a pendulum, and that should make sense, right? So the angle and the mass don't affect it because all objects accelerate at the same rate when they're dropped, right? 10 meters per second squared, or more precisely 9.81 meters per second squared. So when you drop that pendulum, no matter the mass, it's going to be accelerating at the same rate, right? So You'll want to make sure that you understand these relationships. If you were to see this on a quiz coming up, you would be able to tell me which of these things affects the period of a pendulum and which of them has no effect on the period of a pendulum.